You are listening to Humanities Engaged, where we take a closer look at the value of a liberal arts education. I'm Steve McFarland, and I teach philosophy in the Division of Humanities at the University of Minnesota Morris. I'm joined by UMM student and brains of the operation, Adam Kretz. Say hi, Adam.
Hey there, everybody. Thank you for listening. You'll hear me chime in occasionally during the interview with a couple questions, and I'll join Steve afterwards to discuss what we learned.
We are coming to you from the University of Minnesota Morris, made possible with funding from the Mellon Foundation. Please join us as we interview UMM faculty to learn how they teach and why they teach. Today's guest is Dr. Nancy Carpenter. Dr. Carpenter is a member of the chemistry department in the Division of Math and Science. She received her Ph.D. from Northwestern University, and she's the recipient of the Alumni Association Teaching Award and the Horace T. Morse Minnesota Alumni Association Award. We bring you now to our interview.
My mom was a stay-at-home mom, raising the family, and she had college training as she changed her answer quite a bit, but she basically had a major in biology. She said it was zoology. And so she was always really interested in science. And my dad was a physician. So science was something I was exposed to quite a bit. And I can remember she gave me a book, or I guess they gave me a book when I was a little kid called Science in Your Own Backyard. That was a pretty cool, just explore around in your own backyard. So I was kind of brought up being interested in that kind of digging around and discovering. And so my mom was big influence on me, and she said, you should take chemistry in high school. And I did. And I took chemistry and physics. She made me take physics too, which of course you have to do if you're interested in chemistry. And I was the only girl in my high school physics class. And in chemistry, which I did actually like a lot in high school, I was not the only girl, but I was one of a few. And at some point, they were choosing students to go to the state competition for chemistry, high school chemistry students. And I'm not, my memory's probably not crystal clear on this, but if I wasn't the top scoring student, I was one of the top scoring students, and they didn't choose me. And I told my mom that, and she was furious. And she, raised a ruckus. And I ended up going with one of my friends, a young man, and we both did terribly. But it was the principle of the thing, right?
Right.
So my mom is probably the main person responsible for getting me into chemistry. And then when I went to college, I went, you start with general chemistry, and at the end of general chemistry, and I can point you to the lines in my journal that say, or it was a letter to my mom or something like that. I just took my final in general chemistry. Thank God that's over. I am never going to take another chemistry class again, because I did not care for Gen Chem at all. And my advisor in undergrad said, I know you said you're done with chemistry, but you really should take organic chemistry, because Charles Lowry is teaching it next year, and he's really good. And that was it. Yeah, that was all it took.
The advisor giving you the extra nudge.
Yeah, right.
So could you speak to, because you mentioned like initially exploring in the backyard, and and so I'd be curious, kind of how does that maybe relate to your interest in chemistry? Because sometimes the sense I get is chemistry is very like it's just this separate language, and you learn this language, and so I'd be curious maybe how it relates, or just what about your earlier experience in high school or with that advisor that maybe captivated you and catapulted such a long-standing interest?
Well, I'd say the science in your own backyard thing was mainly look around you, open your eyes, dig deep. There's so much to see. And I think one thing about chemistry is the unknown, the invisible. We can't look in a microscope and see molecules. We right. At this stage can't see atoms, with fancy schmancy equipment. Yes, you can. But so I think that was the connection for that. And then the high school, and this just capital D dork capital G, geek here. So if any of my students listen to this, they'll laugh. But basically, organic chemistry has a very specific naming system. It's very spelled out, very pattern-oriented. And it's so logical, and it's so sensible. And I just thought that was the coolest thing in the world.
Oh, interesting.
That you could name any molecule in the world based on these, basically something like 10 rules. I found that fascinating. And so that's why I loved chemistry in high school, which is pretty geeky.
It was like maybe something you didn't see in any of your other classes.
Oh no. Maybe it should have been seen in my math classes, probably, algebra, basic algebra, but I don't know, something about it, because it was a language. I mean, because it was real words. Maybe that's why it connected.
Cool.
Yes, so I think that a common thing with experts versus novices, and there's some research that relates to some of this stuff. So for instance, an experiment asked experts to draw pictures of like a neuron or some like scientific concept.
Yeah.
And they asked undergrads to draw it who were studying it. And the drawings are very different, right?
I'm sure.
And I think experts can like identify structures more. Not that they don't have expertise in like individual items and so on.
Right.
But they figure out like what's the causal story, and that's like the main thing, or the constraints on like the formation of some physical phenomenon or something like that. And then they'll tell you that's the main thing you need to know. But in the undergrads have these very detailed, very specific, every little details in the picture, and the experts just draw like very simple diagrams or something like that.
I think the experts see the forest,
yeah.
and the undergrads are learning the trees,
right?
And I think that's what we're trying to get them to the forest.
Yeah,
and it takes a lot of trees before you can see a forest. You see one tree, it's not going to do the trick.
And it seems like you kind of zoomed in quickly on the structure in organic chemistry.
I did.
The underlying rationale and the...
Oh, I think so. And I think this instructor, this Dr. Lowry, I mean, you can teach organic chemistry in different ways. And, if you're familiar at all with organic chemistry, the reputation is that it's the hardest class and it's the pre-med killer and all of this stuff, and that you just have to memorize everything. And you don't. You have to look for the pattern. You have to understand the pattern. And so I think that's what Dr. Lowry did. He emphasized the pattern, whereas some teachers will say, you need to memorize all this stuff.
Yeah. I
liken it to learning how to play the piano. Learning the basics of playing the piano, you have to learn how to play the scales, right?
Right.
And I played piano. I had to learn how to do that. And to me, it was you memorized everything. And it was not until I was an adult and teaching organic chemistry that I understood through a different pathway that all of the scales have the same exact pattern.
Yeah.
I never knew that.
Yeah.
I knew I just had to memorize every friggin' D minor, C major, B flat, whatever. It's just annoying, right?
Yeah.
But if you just understood that one pattern, how much more powerful is that?
Yeah.
So
let's get into that. So how do you get your students to see the patterns that you're hoping they see? So do you structure the course a certain way? Do you think about the assignments that you give? Or are they designed to try to?
Well, I think so. It's really, really hard because it's so much easier not to do that. In organic chemistry, the pattern is called the mechanism, and it relies on basic, fundamental, abstract concepts that are kind of hard to wrap your head around. I mean, you have to think like a molecule, whatever that means. What?
I do that all the time.
Yeah,
right? That's
yeah, sure. Well, at least we're not making you think like atoms, right?
Well, yeah. Could you give us a sense of what thinking like a molecule is, if it doesn't take us too off track? Because that sounds interesting.
Yeah, to me it is. All right, so I have this visual representation of what a molecule of water looks like. It's an H and an O and an H. Well, that's meaningless. That's meaningless. So I try to tell them, It's a big glob of electrons. Well, what are electrons? Well, think of magnets, think of charge, right? It's a big glob of charge, negative charge, all right? And if you start thinking about not just one isolated glob, but a beaker full of these globs, you begin to get a sense of the macroscopic picture, right? And then you have to think about other aspects of the molecule in terms of the physical properties. Everything in this room, everything on this planet can be explained pretty much on the basis of the physical properties of these molecules. And so if you just get down to start thinking about, hey, there's this glob of electron density over here that's attracted to this glob of electron density over here because this one's more positively charged and this one's more negatively charged. Think about that. That pattern doesn't change. The positive is always attracted to the negative. It never changes. It doesn't matter what the reaction is. It doesn't matter what the phenomenon is. So if you can get down to this abstract concept of these things from this stand of this microphone to the table to whatever are actually globs of electron density, you'd be amazed at what you can think about. You too can make a new polymer. You too can come up with a new film for a solar cell. It's power beyond belief. Yeah.
And so you're saying that so you try to get then your students to think about this, but structuring assignments to that end is difficult.
Well, you have to be. I think you have to be very deliberate, and focus on the abstract basics, not just spit back. Right? Explain to this. Why is it this way? Why would it go like this? And particularly when you're just doing the spit back thing, you're just trying to remember the answer is this because I remember seeing it on page whatever.
Right.
And it's not right. Well, let's figure out why it's not right. So always going back to that. Why would it be this and not that? Always doing the hard part. The hard part is the thinking about it.
So you try to get like the students out of the memorization game, at least insert the kind of abstract thinking as a part of that memorization game.
Correct. Because in terms of the liberal arts, is chemistry part of the liberal arts? Absolutely. Absolutely. Because my students, 95% of my students, are never going to use the reactions again, okay? But 100% of them, if they are successful, will learn this process of thinking about things. It's brain exercise. It's just a different way, just like every class has its own way of approaching problems. Philosophy, writing. I mean, the hardest class I've ever taken was creative writing, not organic chemistry.
Yeah.
So it's just another way of solving problems and figuring out how to approach a problem and figure it out. And, in the organic chemistry laboratory, in the introductory laboratory, we have, a lab manual, but life has no lab manual. When you get out there, no matter what the problem is, it's up to you. And you have to rely on the tools you learned in organic chemistry to solve this problem at your school? Yeah. A lot of pre-meds have to take organic chemistry. Well, they don't make new molecules, do they? No, and they do need to know the biochemistry and so on and so forth, but it's more this is a huge problem. How do I begin to solve it? How do I break it down and come up with an approach that makes sense and actually gets to the solution?
Yeah, and there's a cognitive scientist named Daniel Willingham who says he studies K through 12 education, and I think in particular reading, but I don't think just reading. And he says if you want to get better readers, teach students science. Teach them literature, because there's so much about the content of what you're reading that if you don't understand it, and if you don't know the metaphors and the allusions and the actual theories and, if you like, a lot of people know who Albert Einstein is, but how many people have any sense at all what E equals MC squared is at all?
Right.
And if you know what it is at all, like I don't know really what it is, but I know roughly what it is, and that helps me understand relationships between all kinds of things elsewhere. And I can imagine if you don't know anything about valence shells or electrons or positive negative charge, just the very idea, if anyone brings up there's positive charge, you just skip, in your reading, you don't understand something, you go, I hope I pick up on context cues, but then you never go back. You know what I mean? Yeah. So understanding how the world works, I just can't imagine saying, oh, that doesn't matter at all. You rely on superstition, or you start making up stories or something. Yeah.
And I think and you pay the consequences as a society and a global population.
Yeah. Do you find that Do you find that your knowledge of chemistry? So for if you're super well educated about it, it can kind of turn into background a little bit. I mean, I'm not saying tons, but it seems natural to you that people would say things this way. But if you didn't have that background, you might be like, what does that mean now? Or how does that follow? Do you find that like chemistry comes up in like normal contexts where having your background really helps you have a different perspective on it than if you didn't have that background?
Chemistry, the only time chemistry comes up with any kind of frequency in the real world, away from my professional career, is when you're reading in the popular press or on, TV or radio that something is chemical free.
Right.
And right. that is
good luck.
That's when all of the chemists in the world, they go ballistic.
Right.
So I mean I'd say we're very attentive to that. And I think you think about things from a different perspective, and maybe it goes all the way back to that book. You look at something, geez, that is so cool. I wonder why it does that, and you go down to the molecular level. You say, wow, I wonder what's going on here.
Yeah.
So I don't know if that's really getting at your question, but
so it can, even like on a consumer level, chemistry can be relevant if you have some understanding.
Super duper.
Yeah.
Yeah, absolutely. I mean, it would be nice. A lot of, this is a gross generalization, but a lot of the elementary school teachers that I know or know of are elementary school teachers because they're terrified of science and just want to stay away from it because it's just frightening. It's too hard. It's too opaque, whatever. And that's a darn shame, because kids, middle school, elementary school, man, that's the most fun time to just play and take things apart and discover and learn about how the world works. And something happens between that and junior high, high school, where we just say, oh, no, don't have fun anymore. Just give me the right answer, Yeah. So.
Yeah. Do you have? Is there fun in your classes? Do you bring fun into the mix in any direct way that you could tell us about?
Well, I could tell you one story, but I'm not going to because I don't want to get in trouble. But
you are on microphone.
Yeah, right. We bring in demos. So I teach a flipped classroom.
Okay, cool.
And I think that's a lot more fun than...
Can you explain what you take?
Yeah, we'd love to hear all about this.
Okay, so basically, some years ago, I had to go to a conference in the middle of a semester, and I had already been recording my pre-lab lectures for the lab course. I was going to be gone for at least 2 lectures for this conference. I'm like, well, I'll go ahead and record my lectures and see how that goes. Well, I had some students come up to me after that and said, oh, man, I really loved that because I could pause the lecture and take notes and go back and replay it, and that was really great. I mean, this was not, flipped learning had already started. I was no discovery of mine. But I was like, oh, this is, it just makes sense. I mean, everything that they would ever need to learn, they can get off the internet anyway So I might as well just try this. So I did an EDP grant and flipped the classroom. So I've been doing it like maybe 5 years or so. And it's not for everybody. You really have to be self-motivated, but I have all my lectures in little, at most 20 minutes. They think that's way too long. So 10 to 20 minute mini lectures that they look at, my students look at outside of class. And then in class, we apply. And I mean, that's what I was trying to do anyway prior to flipping the classroom. I was trying to do less content. That's why you buy the textbook. You can read, right? Let's do the hard part. Let's make sure we can understand it and apply this stuff. So that's what we do. We have worksheets. We go to the board. We, like I said, we do demos. It's invariably, well, almost invariably group work. So you're, explaining things to each other, trying to figure these problems out together. So I really think it's certainly a lot more fun for me. It's still hard work, so I'm not sure any of my students are going to say, wow, I can hardly wait to get to OChem. But I do think it is a lot more engaging way to learn.
Yeah, and hard work plus progress, I think, is better than I don't understand anything, I zone out, and I hope I get a B on the exam.
Right, yeah.
I think if you feel like if you're progressing, I don't think people don't like hard work. I think they don't like hard work where they don't feel there's a payoff to it.
They don't go anywhere.
Yeah.
Right. Yeah, I've worked and it's not paying off. That's very frustrating.
So it's I find it interesting because in some of my classes, I've definitely had these classes where I've found myself wondering, I'm like, we're all like racing to take notes,
right.
The whole
right.
class long,
right.
and then there's always these moments where the professor goes, any questions, and there's like a 30-second
right.
window.
Yeah.
And so I'm really interested by kind of what you're describing. And so, is there any, I don't know if you have one, but is there any like example that comes to mind where you're like, wow, I was doing it before where, I was kind of doing the lecture in class, and now I'm doing these small lectures where the students were able to stop and play. Is there anything that you noticed where an example of a kind of more engaging, because you said they were more engaged and doing more. Is there like an example you could give of that where it's like, before, I just don't even think they grasped this concept. I don't even think they saw how cool this was or something like that.
All I can say, I will be honest and say, I personally can't say that I have seen an improvement in overall performance. So I think there's definitely a self-selection because we have sections where they're flipped and not flipped.
Okay.
So while I think if you look in the education literature, you can find results that say flipped learning is more effective at blah, blah, blah. I don't think I can say because I flipped a class, my students perform better.
Interesting.
But they are unbelievably more engaged. And for example, back in the day when I was primarily lecturing, on occasion, we do something at the board. It's kind of like pulling teeth, right? Nobody wants to go to the board. Nobody wants to get up there and do anything. But I'll put a problem on the board now and, okay, have at it. And sometimes there's, elbows jostling.
Wow, okay.
Not everybody.
Sure.
Not everybody, but there's still plenty of people who really are eager to get up there and start chewing on this problem.
Nice.
So I just think it's really fun.
Yeah, that's like a night and day difference for some people there.
Yeah.
So that's interesting. So people are more engaged, but you're not necessarily noticing any achievement difference or something like that, or learning. Learning. What do you think? There's like an assessment issue there, or so why wouldn't more engagement lead to improved learning outcomes?
That's a great question. I would think it would.
Yeah.
And I take responsibility.
Well, I know.
No, I'm not saying that you're trying to say, what are you doing wrong? But I do think, I think I've evolved as a flipped learning teacher. I can tell you the first year was pretty rough.
Yeah.
And I think, I don't want my current students to get big heads or anything, but I think they're doing a fantastic job.
Yeah.
So maybe, I haven't really assessed it. This is just kind of a general
Right.
observation.
Mm-hmm.
So maybe there has been some improvement.
Well, I still think it's kind of remarkable that you're changing your teaching style. You've been teaching, and at this stage, you're still innovating. You're still thinking about how can I do something different. And
how could you not? I mean, I know this is just my opinion, but I mean, I just that just hit me like a ton of bricks. Why do you even need me?
Mm-hmm.
You can get everything off the internet.
Right.
How do you need me? You need me to help you understand how to solve these problems. I do not deliver content. That is, I do over the mini lectures, but the main value for them from me is to work with them during the in-class time and say, okay, now let's approach it this way. What do you think about this? That's where I'm used to. The internet can't help you with that.
Right.
But a live human being who has some expertise can.
Yeah, I think I think that's a great way to think about it, and I think about it similarly too. So the value added, what are you getting from me? What are you getting from this class? What are you getting from this reading? What are you getting from this writing this assignment? How is this doing better than the alternative, rather than this is just like how it's done or something like that?
Right. But I will also say that it's fascinating to me that because we do have two sections, I mean, some students just don't want to do it.
Yeah.
They don't want that. They want the sage on the stage. I want to sit in class and take notes.
Yeah, Adam, in these interviews, it's come up where some ideas seem great, but you have to have uptake from the students. There's just no substitute for the student wanting, putting their effort into it and putting themselves into it.
Right. Yeah.
So one thing we've been asking all the professors is just, we've got this great opportunity to have students listen to this and hear from professors in a different kind of setting here. And I'm curious because all the professors have, I think most of them have, they've all gone to grad school, and much of them have gotten a PhD. And so you folks have been students for quite a long time yourselves.
Professional students.
Yeah, professional students. So now that you're in this, you've been teaching for a while, what advice do you have for students to get the most out of their education? And you've already maybe, talked about how that works in your class, but maybe just in general, or if you want to speak more specifically to some of your classes, like we've had professors talks about like little hacks such as writing in the marginalia, like that's one way to improve just, engagement on that level, going to office hours. So is there any hacks that you have as a student, or just things to do or be aware of to improve your learning in your courses?
Well, I mean, I guess the most important quote-unquote key to success, as far as I'm concerned, is time management. Just being organized. Figure out, until it is routine, until it's just second nature, figure out how you're going to schedule your day, week, whatever. And, you need to build in time for exercise or downtime or meditation or whatever it is. But, you need to get used to a schedule so that you're not constantly putting out fires, okay? Because that doesn't work. What I try to tell my students, and I think this is just hard, is if you have to just keep asking why. Keep drilling down. Okay, the answer is blah, blah, blah. Well, why? Well, because blah, blah, blah. But why that? Well, because blah, blah, blah. When you've exhausted all your whys, then you really understand it. And then, of course, the best way to make sure you really understand it is to explain it to somebody else. As long as not everybody wants to have a study partner or work in a group, and that I understand. But when I was an undergrad and studying, I would go into a library, Carol, and they had blackboards then. Imagine that with chalk.
What is chalk?
Yeah, what is
Could
this
you
thing
explain that
called
for our
chalk?
audience?
It's calcium carbonate, actually. And I just explained everything in great gory detail, on the chalkboard. So I'd say those are the hacks that work for me. But bottom line is time management.
Yeah, great. I don't think we've heard that one, so that's cool.
Yeah.
So is there a big, you've talked about some of these already, you've touched on them at least. Is there a big substantive idea from chemistry that you hope all of your students 20 years from now take away, even if they can't remember every little detail? This is a thing that after you take a chemistry class, I want you to remember this, right?
Well, probably the obvious one is everything is made up of molecules, right?
Mm-hmm.
And molecules can be good and molecules can be bad. And the problems that we face now are made by molecules, climate change, but they're going to be solved by molecules. So I guess that's kind of the overarching, boy, take that home with you.
Yeah, the joke before about chemical free is that unless it's empty space, it's
right.
It's
black
chemicals.
hole.
Yeah,
right. Yeah. Right.
Is there a methodological idea so far as to think like a chemist?
Well, in organic chemistry, to me, the ultimate problem-solving skill is to do synthesis.
Mm-hmm.
And basically that means looking at a molecule that's kind of intimidating and figuring out how you would break it down into its constituent parts and come up with a way to make it. That's really, really difficult. It's something a skill that you have to work your way into. And if you get that skill, it's kind of like what I was alluding to earlier, at the problem-solving skill, that when you're out there and faced with this pretty giant problem that's totally overwhelming, if you can just say, no, wait a minute. Yeah, how can I take one step backwards? That's what I always say, one step backwards, and turn this huge problem into two smaller problems. And then I'll take that one of those two smaller problems and break it down into yet two more smaller problems.
Yeah.
And it becomes manageable.
Yeah, and that's not metaphorical in this case, but it seems
Yeah.
like it could be metaphorical for just any kind of intellectual problem you have. Is, you're writing a philosophy paper, and students flip out, and it's don't write it in one night. Don't
Right.
write 10 pages in one
Right.
night. You break it into parts. Have an outline, and then you have the sections. So
Right.
in your case, it's not metaphorical, but it seems
Yeah.
to apply more generally. Of
Yeah.
analyze each piece, take each piece on.
Right.
Then at the end, you'll be farther than you thought in terms
Right.
of tackling
Right.
the problem.
And it's eminently doable by you.
Yeah.
You can do it. Yeah.
Then finally, we ask everybody if you have resources where people could learn more about the things you're interested in. So we usually hope for something that's a bit aimed at a general audience who might not have hardly any background in chemistry. It could be podcasts, videos, reading, internet source, something like that. And then maybe something a little bit, if people have a little bit of background already, where they could learn more.
Well, I mean, there's just so many good books about chemistry, like Primo Levi's The Periodic Table is a great book. The Compound Chemistry website is great fun. That's a good one for the layperson to see, the everyday applications of chemistry in their lives.
Is it what's that have on there? The compound chemistry.
Well, they'll do a topic per day, like the chemistry of perfumes or the chemistry of ice cream,
right?
Or things like that. So that's pretty fun.
Yeah.
So.
Okay.
Cool. So sorry, we have it's 9:37. You got maybe a minute for another one, because I think you class with Duncan.
Oh, Vermilion?
Yeah.
Oh, yeah.
Yeah. So me and Duncan are friends, and I was telling him we were going to interview you, and I think I'm remembering this correctly, but he said, like, I guess the one thing that you do that's kind of unique is, I guess you have like a chemistry today, or like a kind of chemistry in the world kind of like orientation to some of your teaching, is seeing it in the world. Maybe I'm misremembering.
I do try to bring in examples that are recently in the news or have been recently published.
Okay. Yeah, I think that's maybe what he was like appreciating is not just purely drilling into.
Oh my gosh, no. Yeah.
Yeah, so I was just curious about if you could give any interesting examples of that, because that just seems interesting to me, and it might be to other people, like how it's fitting in.
You can bring in molecules that have medicinal applications and use those. I mean, they're being published all the time, and bring those in and say, as a demonstration of how much you've learned. You can even go back to the very, very basics of organic chemistry and say, hey, look, you can see that this would cross the blood-brain barrier, for example, because of this functional group or this solubility property or whatever.
I think that's so useful in a general way. All of us use medications. All of us are putting stuff in our bodies. How could that not be a relevant, idea to obviously most of these people aren't going to make these chemicals, but just to know, like, this is what it's doing
and it's so empowering.
Yeah.
You have learned the basics that allow you to understand how this anti-cancer agent works.
Yeah.
That's fantastic.
Yeah, I think it's cool that you do that, because I think the thing that I find similarly empowering with philosophy is we learn the basic logic of arguments and stuff like that, and then I can go and listen to a podcast or read an article, and I could be like, okay, so this is the premise that they have, this is like this unstated assumption that they're making, and all of a sudden, I've like seeing it in a totally new way, empowered by the skills I've learned. So that's cool that you do that in your class with chemistry.
A liberal arts education is a wonderful thing.
Well said. So thank you very much.
Well, thank you. It's been fun.
Cool.
Thanks again to Nancy Carpenter. Adam, what did we learn today?
Yeah, so the one thing that I found interesting is, she talked about how these mini lectures that she puts online that the students can see prior to coming to class are a lot more valuable, because at the end of the day, the students have access to this information through so many different sources, because they have access to the internet, they have access to the library, they have access to research articles through databases and so forth and so on. And so she said, why do they need me to lecture on this if the information is available? And this is something that has kind of irked me, and I've gone to 2 community colleges, and now I'm at university here. So it's just one thing that's come up again and again is I've always wondered, in situations where the class is just lecture and not discussion oriented or oriented around some type of activity, I wondered, why are we doing this? Because we're all here. We're all together. This could be done online. And so if we have a special opportunity because we're all physically together, why aren't we taking advantage of that? It's always really baffled me. And it kind of seemed like that was the thing she was touching on. She's just like, oh yeah, it just doesn't make sense to utilize our time this way. And so I really appreciated that, because I think sometimes as a student, I wonder if other students feel this way. I've thought, well, I just must be wrong. They must know what they're doing. But it is the case that there are different ways to do things.
Yeah, I think that's right. So there's value in having experts give their expert opinion or expert narrative or some kind of lecture if they're adding something that's unique to them. But a lot of teaching isn't like that, right? It's saying it's a one-on-one, whatever the econ or chemistry or physics or something like that. And so there's not something unique about this particular person teaching intro class or something like that many times. How their ideas are very influential. There are differences in the teaching styles and things like that, or lecture styles. I'm not trying to deny that, but the information itself is not something that's accessible to only this expert who's giving their ideas that no one else has. In fact, you're trying to convey standard ideas that everybody should have. So I do think that there's something to this critique that just someone standing up there and just talking at you and you just write down and recall, it's fair to question the value of that.
Yeah, and I'll just again kind of clarify. It's not it's certainly not that I don't see any value in a lecture.
Mm-hmm.
It's just that we have this unique opportunity to be here together. And why not have some good amount of that time dedicated to discussing things, or like we've talked about, some teachers have activities that they find especially valuable for retaining or understanding the information. And so that's just kind of where the critique comes from for me, is we have this special opportunity. I wish we could do more with it. I wish I could interact with my fellow students a little bit more.
Yeah, so I don't know. You've had classes with me. How would you characterize the lecture discussion activity ratio in my classes?
Yeah, I feel like you give it's like a real genuine effort to have discussion on certain points. Whereas I think I mentioned in the interview, sometimes it's just like, any questions? And it's not really intended to open up a discussion.
Okay.
And so I think in your classes, you give a real opportunity to have us chime in, and I think I've even had back and forths with other students, and that is just so cool to me, and that's great, because then it's, I don't know, at least for me, when I have like some other student like challenge my idea in class, then it really forces me to think about what I said.
Yeah.
And so, yeah, I definitely think that's something you do in your classes, and I wish I had more opportunities for that in other classes.
Okay, so I wasn't fishing for a compliment, but thank you. But but the thing I was thinking about is I do lecture some, and and not just a little bit. And so I'm thinking out loud a little bit about how what I try to do though is convey these ideas in a different way than you saw it in the text, or draw some things together, or use an analogy that I think that my students will be able to connect with, and then take that and apply it back to this other thing that the author of the textbook or whatever book didn't do. And so I wonder how much different disciplines lend themselves to lecture versus non-lecture. I think it might not be one and the same for each discipline. Might be no one size fits all to the perfect amount of lecturing versus discussion versus activity, or whatever the case may be. So there just might be some, so for instance, if I teach, I'm teaching ancient philosophy this semester, and we're reading Plato and Aristotle. And some of Aristotle's works are viewed as some of the most difficult texts in the canon, right? And if I have students if I just say, okay, just do the reading, and you can find online what Aristotle says, I just don't think it'll be right there in terms of what I'm hoping that they get out of it. And so I do feel like I need to say a little bit to get them, like some step ladders into where maybe they could do more on their own in the first place. I don't think I could just let them go and they would get to the level of understanding that I'm hoping for from them. They could get some, obviously, but maybe in a philosophy class that has like a little bit easier of a topic that they can get into easier, maybe I should pull in the reins on lecture a little bit. Maybe they don't need me to be drawing these connections for them as much. And I do wonder about, if I'm working so hard to draw these connections for them, if I could act as something of a crutch, where they think, well, I don't need to do the reading and I don't need to think hard about this because the teacher will just tell me, and I just need to remember what the teacher says. And so I do sometimes worry about that kind of enabling cognitive laziness and breaking it down so much for the students that they don't try to break it down for themselves. I don't worry about that a lot in my philosophy classes because it's a lot of times difficult material, but I do think about it.
Yeah, I mean, I've had a class where there's an essay part of the test, and if you just write down exactly what the professor wrote in the notes, you get all the points. Mm-hmm. Now, one could argue it's like, oh, well, the way they wrote it up is the best way to understand it. But it also can be, limited in the sense that, well, I just have to memorize it. I don't have to reiterate this in my own words or really grasp it for myself. I just need to reiterate it in the exact fashion.
I've come across teachers that do the hidden grade rubric for essays, on either written essays or on exams, and they say, look, if they didn't use this keyword, that's -2. If they didn't use that keyword, it's -2. If they didn't include that word, it's -1. And I just want to say to those teachers, I don't think that that's the best way to do things. If you want them to say a word, you should tell them that they should say that word. If you want them to present their own ideas in an essay format, then of course they should include key concepts. I'm not saying that. I'm saying if you have the secret grading rubric of if they say that word, they get the credit. If they don't say the word, they don't get the credit. That is not encouraging them to think through the ideas for themselves. That's, you better have remember what I said and then read my mind when I asked this question to make sure that you are saying what I said, and you should know that, even though I say write an essay about what you think. That's not the same as, of course, you have to have students to define key terms. Of course, there's concepts they need to mention. I'm talking about a secret rubric that I have definitely seen. I'm not making this up, where it was there's 15 words they need to mention. It's 2 points each for each word, or something like that.
One kind of related question as we wind down here. If you could have, by the end of the semester, your students have a shallow grasp of many things or a firm grasp of a few things, which would you prefer as a teacher?
I don't know the answer to that. I think that if, like Dr. Carpenter was saying, I think what a lot of experts think, and I'm inclined to agree, is that if you learn a few deep things, it helps you figure out a lot of shallow things. That you don't have to have an either or here, but if you learn a lot of shallow things, that won't necessarily get you to learning the deep things. So, as she was saying, once you learn the 10 rules for naming chemicals, you know how to name the next new one. Or you could go the other way and just learn every chemical name, right? But if you know the rules, then you know how to do the next maneuver. And in my classes, so there's ethical theories, right? Utilitarianism, which is do the what will be the greatest good for the greatest number of people, right? I have a really strong goal in my classes where I'm teaching utilitarianism, that they know how to think like a utilitarian about a new ethical issue. So if I said, okay, what should they say about, affirmative action if you're utilitarian? And then I say, what would they say about euthanasia if you're utilitarian? Then you always know, like, at least at a, first attempt at what a utilitarian would say each one, right? So that deeper knowledge gives you, it builds up to lots of shallow knowledge if you can apply it.
Yeah, definitely. I see that, and I think that's a cool thing that happens when you do learn some of these things more in depth.
Hopefully.
Just as a parting thought, I mean, raising some critiques here, and I'm just kind of exploring this stuff and thinking about it, and so, to some of the stuff that I talked about, I'm not saying it's definitely wrong or bad, just kind of noticing things and airing them out. And that concludes this episode. Links to the references our guest mentioned can be found in the show notes. Before we go here, a big thank you to the Mellon Foundation and the Humanities Division for supporting this podcast. The views and opinions expressed are solely those of the individuals participating and do not represent the University of Minnesota Morris or the University of Minnesota system. You can find our podcast on iTunes or anywhere you get your podcasts. And if you want to help out the show, please leave us a review on the iTunes store or share the podcast with others. Thanks for listening.
This has been Humanities Engaged.